Good afternoon. Welcome to the Dicom Systems webinar series. Today we'll be talking about enterprise imaging performance benchmarking with our guest Trevor Walker of Stanford Health Care. All right, we do invite everyone to contribute to the conversation. We'll be taking questions at the end, and what you do is just submit your questions into the control panel there, and that will be viewed by the organizers. If we aren't able to answer your question today, we will follow up.
Great. And Taylor, we don't see your screen. This is Dmitriy Tochilnk, Dicom Systems President and CTO. So I'll be part of this webinar. Taylor, I don't think we can see your screen yet.
Okay, Dmitry, it might be because you have control of the screen. Can you see if you can switch that over to me?
Absolutely.
Okay. All right, thank you. All right, today's speakers, we do have on Dmitriy Tochilnk, President and CTO of Dicom Systems, and Trevor Walker, Principal Systems Analyst of Stanford Health Care. Welcome, gentlemen.
Thank you.
Thank you.
About Dicom Systems, we are a leader in enterprise imaging and teleradiology workflow solutions. We're known for our signature workflow unifier and archive platform, which delivers a breadth of features that includes smart routing, SSL-based Dicom and HL7 integration tools, Dicom modality worklist, a new load balancer, which we're unveiling at SIM, VNA, and business continuity and disaster relief through on-premise, private cloud, and leading cloud providers, including Google Cloud, AWS, and Azure. We're actually live on Google Cloud. You can create an account on Launcher and spin up an instance, and that's available now. We are proven at worldwide deployments and recognized by top healthcare enterprises, government agencies, and partners for next generation enterprise imaging interoperability. If you're attending SIM, we are going to be exhibiting there next month. We're in booth 510, and we invite everybody to come by for a cup of espresso. And Florent St. Clair, our Executive Vice President, will also be on the panel on AI and machine learning. And he is also on the line with us today. All right, well, I'll pass it on to Trevor, who's going to give us some more information about Stanford Health Care and the universe that they operate.
And if I may, I would like to make some introduction. This Stanford Health Care it's a unique organization when they manage their own infrastructure. And Trevor, you guys have a full control over your hardware and network versus some of other organizations that letting vendor to manage as a turnkey solution. Tell us a little bit more about your infrastructure.
Sure. Our infrastructure team is managed and by Stanford employees. They deploy mainly Cisco hardware for network devices and computing resources, F5 load balancers, VMware for virtualization, and EMC storage. So we have a standard deployment for engaging vendors and deploying their applications on our infrastructure, and use a very standards-based approach to security and application deployment.
Excellent.
And you know, as you can see on the screen here, our imaging landscape is simply a complex mixture of imaging applications, with the main ones being PACS and BNA, but we also have a lot of specialty imaging applications and areas throughout our hospital, whether those be clinical or research teams. As most of you know, those systems work well when they have the images local, but can't store all images local. So we kind of work like the plumbers of medical imaging. So make sure that the systems that need the images have them, and those images are relevant to the workflows that are being supplied with those images.
All right. As a vendor, we always emphasize importance of the solid IT infrastructure as a base of successful deployment. So we really like this plumbing analogy that of the industry, and this is what primarily Unifier does. We're making sure we deliver a water at the right pressure, at the right temperature, and most important, at the right time. If you open your shower valve and you have to wait for 10 minutes for the water to come out, or another 10 minutes for the hot water, it can affect your schedule and your overall performance. So because we are connected to the system from downstream and upstream, the flow of images and messages tied to the solid IT infrastructure, such as network and storage.
Ready for the next slide?
Yeah, I think we're ready for the next slide. And Dicom Systems Unifier is a tool set that with many modules and have lots of bells and whistles. Every organization uses it a little bit different for the different. We also sometimes refer to as Swiss Army knives, and every organization uses it as a different blades. They need the different blades to solve different problem. So Trevor, can you share a little bit more about Stanford technology stack and how Unifier is being used at Stanford? So Trevor, you might be on mute.
Yeah, thank you. So as I described before, our IT infrastructure team deploys mainly Cisco equipment for network and computing resources. UCS is their computing platform. F5 load balancers and Dell EMC Isilon for storage. Specifically for the Dicom Systems Unifier, we deploy several VMs, and those VMs are kind of tagged as logically as the what they function for. So we have a set of VMs that handle image routing, a set of VMs that handle modality worklist proxy, and another set of VMs that actually handle QR proxy when it comes to a large user or exerciser of the QR functionality. And mainly those downstream systems are our GE, our PACS system that we send and retrieve from, send studies to and retrieve from. We also have our modality worklist that comes from another source. So the fact that we're able to actually configure most modalities and other imaging systems with some simple configuration, which is the Stanford VIP that points to the Dicom Systems Unifiers VMs, greatly improves our flexibility and in terms of systems that may go through an upgrade, like if we were to change a particular clinical environment software, we have the ability to do that fairly quickly with this without another modality migration.
Perfect. Excellent. So some of them, it's basically during the implementation and also during go live and post go live, data benchmarking is very important You want to make sure you have consistent measure and result aligned with your requirement. For example, if you only have SATA disk with the limited I/O throughput, then you need to move one exam with 1,000 slices CT with 4 prior exam, for example. It would take at least 5 minutes just the disk speed wise to move that, assuming you don't have anything else in the queue. So after this exercise, you might consider to upgrade to SSD.
Yeah, and as Dmitry mentioned there, before we did, we actually did a conversion from the physical Dicom systems cluster to virtual machines, and we actually performed all of these tools on the VM. We deployed the VM in a testing and staging scenario, made sure that the I/O and the network speed were sufficient to handle the workload of the traffic that we were going to push through it.
Yeah, this is an excellent point, because we using different tools to benchmark I/O memory and CPU during different type of day is important. It's important to save that reference of benchmarking data during the go live and pre and post go live scenario to confirm that it doesn't change over time. Example, if you see degraded performance, let's say change 6 months after deployment, you might want to perform the same set of procedure to confirm that result is still the same, and problem lies somewhere else. And we basically had that exercise before, and it was very successful. So I think we're ready for the next slide, Taylor. This is an example of metrics, detailing metric. Usually our system are in the middle of the transfer, upstream and downstream. We can have problem upstream and downstream. And to have all the real-time detailed metric, it's important to solve any type of issue as they come up. So this is example what you can see in terms of incoming and outgoing data. So it's really important to see number of association. So you can see number of images sent here. There is more detailed view where every image being received. It's not going to fit on the screen. There is a lot of images, and you can actually on the bottom of the screen you can see absolute speed on receive. So which is pretty good. It's around 70 megabytes per second. But and you can see it was sent at burst, in series from modality, which is pretty normal. And you can see some delay in send, so they basically modality sent as data being received.
And this is, if you might jump in there, Dmitry, this is very important to Stanford. As I mentioned earlier, we have multiple imaging systems that send data to and from our PACS and other systems. And without the Dicom unifier layer in the middle of that, we really have very little visibility, or let's say varying degrees of visibility into that imaging traffic. And this is an invaluable tool for our troubleshooting if we get, and if we have imaging support teams on the on the call, I'm sure they get these as well, that, hey, my images were sent from the modality and they're not in the PACS. So where do we, even begin to look at that? And right now, our first, investigation step is to hit the Dicom router and look at these statistics and logs that are in the Dicom unifier.
Perfect. Thank you. Glad to hear that. And you can see here as an example, I want to point it out also for a lot of Dicom devices and PACS, they want to receive data as less association as possible. You can see here that incoming you have 7 association, and when it's being sent to the PACS, it is a 3. So what you also can see on the screen that you can see the speed for the incoming data, it's way higher than outgoing. So somewhere you see the problem of the throughput from upstream to the system. So that's something can be improved, because you can see consistently trying to send, but somehow you hit the limit. So it could be limitation of the receiving system. In the next slide, you can see that overall statistic, that average speed when you send to many all the devices or some of the devices, you can reach average speed 42-26 megabytes. But and the graph down to the slide, you can see that maximum 105 megabytes. So it means that it's really not the software limit to send it out. It lies somewhere else. So which it tells you that you might want to work with vendor to see why you having those throughput issue. Basically, also it's really important to you can see on the screen how the peak traffic versus off-peak traffic and weekend traffic as well. So you can see how it changed during the day. So you want to make sure you architect and you design your system that you can sustain that, not just the average speed and the peak speed, because you can see here the receiving on the graph down at the screen, you can maximum receiving speed 63, outgoing 45. So you want to make sure you and there was a snapshot of the current, and again, it's all in a megabyte. So by looking at this, we can concur that that probably the limitation, it's not the disk. You have a 1 gig network somewhere, that basically that limitation of the outgoing maximum speed here, because we're almost hitting the 1 gig limit for the network. And I assume, Trevor, you have a 1 gig network, right?
I believe it's 10 gig actually.
Yeah, but not for all the system, I guess. So
no, not the modalities connected. No.
Yeah. So basically, that's how you can tell. So if some of the, it's also important if you have 10 gigs. So if it across the board, that it makes sense. But if some of the systems still 1 gig, so then you can really utilize that. So basically, having this metric, I think it's provide visibility to and provide statistic to see where your current bottlenecks are. So, and also for the previous screen, I think, Trevor, you use that to determine the throughput during the day and how it change during the week.
That's exactly correct. Yeah, and I think we may have broadcast on the first slide that we push about 50 terabytes per month, and that's kind of where we get that number. So
okay,
and that's ever increasing as images become more complex and bigger in size, as well as the addition of other systems. We're constantly in flux of supporting existing systems and involved in projects to deploy new or upgrade those existing systems. And yeah, I mean, that's one thing to point out, is that a lot of vendors now are focused on advanced visualization or features like AI and machine learning, but at our hospital, and I'm sure as many others, imaging has become almost a utility, as important as electricity and plumbing to a hospital. So if we have a downtime event, it's very disruptive, and it's all hands on deck to get those systems back up and functioning for the clinical teams.
Great. This is great analogy, I think, electricity and plumbing. I like that. Yeah. So I think, Taylor, we ready for the next one?
Yeah, I was going to have Trevor talk a little bit more about how Stanford Health Care uses image routing and tag morphing.
Sure. So one of the things that the Dicom unifier does very well, and that's smart image routing. One of the things that we have that's unique to us is our PACS was implemented with a different format for patient ID than the RIS is actually supplying. So we have to do a tag morph on any system that, any other system besides the long-term archived PACS. We have to do a tag morphing, and anything that passes in and out of that PACS has to have a tag morph. So without, I think it would be very difficult to have that type of system or support that type of system without an army of vendor support and some analysts. And having that technology at our disposal from the Dicom unifier makes it kind of a non-issue or something that isn't seen very often, and kind of the magic that happens as we configure the Dicom unifier. We also, again, I think I mentioned earlier that with a smart imaging routing and retrieve proxy, we really only ever configure modalities and other imaging systems with the VIP that points to our Dicom unifier. So that makes it very simple for any type of migration. And again, that's the next bullet point. We did go through a PACS migration. Once all the modalities were configured to point to the Dicom router, the PACS migration did not have, a dependency to run around and update all the modalities and other imaging systems. And at Stanford, that would have been a very large manual effort involving, vendors sometimes don't give control to any personnel at the hospital to update those settings. So again, we avoided a very labor-intensive effort to update those modalities by having the Dicom router as that ingestion point and the kind of the funnel or for the proxy for a query retrieve if the system interacted with the PACS via a query retrieve. We've recently added the prior pulling from our PACS to some of our other systems, like our NukeMed and our, we are now working on some of the breast workflows that actually, as the image is ingested from the modality, we do a prior pull and then populate those local caches on other imaging systems. It's been very well received by our clinical staff that there's not an additional step for them to go search for the prior that they're looking for when we pull the most recent priors that are already in the system at the time of their clinical relevance to the physicians.
Great. And Stanford is a big organization. There's a clinical, adult, and pediatrics, as well as research part as a part of your organization. Everyday data movement it's very important at Stanford. How do you handle so much data for both clinical and research side, and how those cross-reference to each other? Trevor?
Yeah. So again, we've deployed the unifier, and that does it does perform very well, and it allows us to offload some of the ingestion pressure and direct query retrieve pressure on our PACS. We do have, like it says here, 60 plus applications that involve data movement to support those clinical workflows. There are also 300 plus modalities that send through the Dicom router to the PACS and these other systems. What was your other question, Dmitry? Could you repeat that?
Yeah, just how you also cross-reference that data between research and the clinical, but I think you partially answered that question.
Yeah. So yeah, they're boiled down to their system components. Those are simply just applications. So yeah, we have I'm not sure of the division, but of those 60 applications, those are supporting clinical workflows as well as research data, which can sometimes be slightly different types of workflows. They're not coming in from a modality, but there's a full patient jacket pull that could pull priors from, up to 20 years ago for a single patient, and that could be somewhat voluminous. So having the ability to throttle that, again, takes the pressure off the PACS itself. It's not a, here I'll touch the PACS right in the middle of the day for this large patient prior jacket pull that may, again, impact the performance. So we are able to see that and funnel that through the unifier QR proxy and then get better control of that.
Understand. This is great.
And yeah, so this is some of the stuff that I mentioned maybe earlier, that our research areas are looking for large data sets for artificial intelligence, machine learning algorithms, stuff that we want to collaborate with vendors and other research institutions. But as you may know, when that data exists on a large monolithic, somewhat dated PACS that served a purpose, 10 to 15 years ago, doesn't necessarily meet that use case very well. So what we're employing some of the future use cases for our Dicom Systems Unifier is to make sure that we can push this data securely while it's in transit and while it's at rest. We can do this in a manner that's safe. We can also anonymize that data if needed for, well, it's actually our preference is to anonymize the data, but if it's needed to be identifiable, we can also do that in a secure manner. Again, encrypted and via transport and secured at rest via the system that we're sending it to.
Mm-hmm. And so what's your future plan about machine learning and cloud? How is it being utilized right now? I know it's a important for research organization, and how much of this effort is kind of future plan versus today's life?
So right now, again, with a monolithic PACS storing about a petabyte of data, it compressed down to maybe 600 terabytes of data. Those are not numbers I should be quoted on, but that's a general estimate. We have a migration effort that pulls those studies out and pushes them to the cloud, but the rate of that migration is simply not enough to be fast enough for the clinical or the research purpose. They would like to investigate getting the data there faster. And with the unifier being our front end off of the modalities, we've made the decision that the best time to get that data to the cloud, and again via secure, well-known technologies, we push it at the point of ingestion so that it doesn't have to go through yet another migration. And again, anybody that's been in this business long enough knows that that's probably the most painful thing to do, is migrate a large chunk of Dicom data.
Yeah,
so
absolutely.
Migration avoidance is one of our key strategic initiatives as we, again, are talking about yet another PACS replacement or enhancement to our existing PACS. We don't want to do. We want to avoid migrations.
Makes sense. Great.
All right, at this time, I'd like to open up the floor to questions, and I see a couple inside the dashboard already, so I'll read them off. We have one here from Maureen, who would like to know if the router has a way to alert users if there is a delay in processing images being pushed to PACS, as in parameters set so that the delays will notify users that the push was successful, but may take longer to display results due to large queue. Who would like to answer that?
Yeah, I think it's a current feature that it's being utilized in Stanford, I believe, right, Trevor?
It is. The users there would be the key piece of information that we would have to identify. Right now, our team gets alerted of queue image ingestion, image routing queues growing to a point where we are concerned, but it is configurable for that.
All right. Okay, thank you, Trevor. The other question is from Dan, and he wants to know, it seems to be a PACS question, but he would be interested in tools or software to benchmark the performance on individual workstation hardware in order to maximize performance without overspending and to prove to management that it is time to upgrade local workstations.
I think it's, we usually work on the server side, and workstation is not the area of our expertise. That's more like a PACS question. But what we'd like to, I'd like to point out, it's still important to measure performance between workstation to the device you're connecting to. In this case, it could be us, could be our device, could be someone else's device. So you want to make sure that performance between where that workstation placed and the server is adequate in terms of the network performance. But the rest is, I mean, it's a client workstation related question, and not particularly related to the software. Because most of the time, all the rendering and processing power happen on a server, unless specific to the particular software you use. When if it's a PACS workstation that requires some processing power and etc. So that
I would agree that you know, and Dan, I'm not sure where you're from, but I would encourage you to speak with your vendor of the software that's loaded on the workstation to see if they have those types of tools. I know some of our vendors are more mature in that regard than others, but there are a few that have some measurement tools that are available, and also they can guide you to some more readily available open source, or if it's not their tool, it would be from another vendor that does that type of activity on workstations.
All right, thank you. Thank you for that. Well, that's all the time that we have today for questions. We thank you for joining us today for Enterprise Imaging Performance Benchmarking. We encourage you to stay in touch with us on Twitter and on LinkedIn. On behalf of Dicom Systems, myself and Dmitry.
Thank you.
Oh, I do see one more question here. Let me just put this in really quick. Okay, we do have a question out there, and it's for Trevor. The question is, when you had Dicom systems installed, were there better things than you expected? Were there anything?
I see. I think so were there features that were available that we didn't necessarily originally scope?
Yes, were there any things that were better than you expected? That was the question.
Yeah, I think, well, I've had some experience with Dicom over the past 10 to 15 years. So Dicom is somewhat of a complex protocol in terms of, you know, performing well. but I was actually very impressed with the flexibility that the Dicom unifier provided. One was the initial rollout of it, even though I wasn't at Stanford when it was selected, was simply to do the image routing. And I believe the QR proxy was talked about. But what it's done for a lot of the rules that you can supply and the filters that you can supply to get very granular on the types of studies that get pulled for priors, I don't think that was ever accounted for. And again, that's been probably one of the more praised study, imaging workflows that we've implemented since I've been at Stanford. And again, I think the overall flexibility and the power of the unifier has been impressive, and I wasn't aware that it could scale so well across multiple unifier instances, which again, those are our VMs. So yeah, there's been a few things. We looked at it as a fairly simple utility to do some Dicom routing, and then once we've gotten it in, we've expanded the use of it and bolstered the infrastructure underneath it to handle that workload. And the flexibility in both of those efforts has been a pleasant surprise.
Thank you, Trevor. Well, we'd like to, again, thank you everyone for being on this webinar. Thank you to Trevor and Stanford Health Care for appearing and partnering with us on providing some education to the public. On behalf of myself and Dmitry, we wish you a great rest of the day, and we hope to see you at SIM in Maryland in just a few weeks. Actually, it's next week. Again, we will be exhibiting there at booth 510, and we welcome you to come visit us. Thank you, and I'll be ending the webinar now.